Tonight, we're very fortunate to have Patrick Rennie from Montana to speak to us. Patrick's been a colleague and friend of mine for many years, more years than either he or I would like to remember. Patrick has his BA from Montana State University in Bozeman and his MA from the University of Montana in Missoula. Both of those are in anthropology. For the last 31 years, he's been the state archaeologist for the Montana Department of Natural Resources and Conservation. That department handles what's called the state school trust land. In Montana, all that state land was chartered to make money for the state school system, which is kind of a good system, actually, until you realize that they got to sell the products off that land. So timber and grazing rights are primarily what happens. There's other things, and I suspect some mining goes on. But a lot of that means extraction, and a lot of things happen there that have potential impacts to archaeology. So Patrick told me when I asked him, I said, I need some information, so I'll give you an introduction. He says, during his 31 years, he has personally inventoried 155,000 acres of the 5.2 million. He calculated what percentage that was. But really what he calculates is at that rate, he only has 500 more years work ahead of him. He figures that's job security in this job. Patrick worked with a number of consulting companies before he got into the government gig. And he was also a State Historic Preservation Office intern. He has been awarded major awards from the director of the DNRC, from the Montana governor, and from the Montana Archaeological Society. So he's no slouch when it comes to this work. He has more than 30 publications on topics as wide-ranging as teepee rings, medicine wheels, and I hope he shows us some medicine wheels tonight. I suspect he will. And for those of you who aren't familiar with medicine wheels, the bighorn medicine wheel is probably the premier example. These are rock structures. Think giant rings of rock with spikes going out here and there and around and about with little ancillary structures at the ends of them. We didn't think there was a lot of those. We thought, oh, there's the bighorn and the Majorville cairn and a couple of others. Well, there's actually quite a few of these things out there laying on the plains, some more complex than others. And Patrick's going to show us some of them. He's also published on quarries, stone quarries, and lithic analysis, on buffalo kills and occupation sites, on artifact caches where folks left groups of artifacts behind to come back to later and for some reason never got there. And right down my wheelhouse, the McAfee site. The McAfee site is Montana's only really good and not well excavated, but good excavated Folsom site. And the McAfee site's always been there in the literature and nobody ever knew a damn thing about it because it was excavated really early on and not very well reported. Patrick took all the data, all the information. It's right outside of Helena where he lives. Mm-hmm. And he has studied that thing till he's wrung every bit of data out of it that you possibly could, from the reports, from the maps, from the artifacts. And he's got this great big report ready to go and get published. And I think it's going to be published in Alberta. Is that right, Patrick?
It is published.
It is published now. He sent me a pre-publication copy and I ate it up. So it's really good. It's really, really a dynamite report. And tonight he's going to talk about it, about using drones, aerial unmanned vehicles, and GIS technology to look at these sites, especially rock ring sites and other archaeological sites, to study them from the air and how much cheaper that is than the old way we used to do it. Patrick, knock us out.
Can everyone hear me? We're good? All right. Well, thank you, Jim. I guess as we begin tonight, the one thing I'd really like to thank, or the one person I'd really like to thank, is Jim for the invite here, be with all of you tonight. Jim, the Oregon Archaeological Society, I hope you understand how lucky you are to have a resource like Jim Kaiser. There's so few like that out there. So draw on him, work with him as much as you can. I mean, his enthusiasm, his passion for this field is what it should be about. And sadly today, I just noticed there's very little passion for this field of archaeology. But Jim is just an incredible archaeologist. So again, thank you, Jim, for the invite tonight. And Jim, one of the reasons I came out here, not that I wouldn't have anyway if I was asked, but Jim has been helping me with rock art sites on school trust land in Montana for a few years now, and just are so fortunate that he was willing. He and his crew, like Dave Minnick, Dave Kaiser, Cindy, all came out, volunteered their time to come out to help me put in several hours. And I shouldn't say me, I mean, I was helping them, but they've been so great because you can't know everything about every kind of archaeological site type out there. You need to rely on your colleagues, other specialists in the field. And Jim is the rock art expert for North America as far as I'm excuse me, as far as I'm concerned. So yeah, anything like that. And I wouldn't limit him to that either. I know this isn't the Jim Kaiser show, but as you can tell, I'm a fan. I'm a fan. So at any rate, thank you again. It's my honor to be here tonight. Now I heard that there are students here interested in drone and robotics. Is that right? Raise your hands. Wow, are you going to be disappointed? Because outside of Kaiser, I'm probably the least techie guy in the room. I don't own a cell phone yet, and I don't even have a wristwatch. So, yeah, by the way, who knows how long this speech is going to go tonight. But at any rate, uh, where I work at the Department of Natural Resources and Conservation in Montana, we started investing in drones about 6 years ago. And right away, they bought these drones, and yet they didn't see much of a use for them. I picked up on it right away. It's like, man, can you come out with me? These guys have to have pilot's license to operate them. And I was too lazy to do that myself, but there's like 7 or 8 licensed drone operators in my department, and they always want an excuse to go out to the field. So that's not a problem, is getting drone operators. Uh, and as I'll talk a little bit more, the we also have the whole GIS, basically a bureau now. So there's a whole fleet of GIS specialists who are out there doing everything from processing the data that I send back to them for archaeological survey or mapping purposes, to our forestry volumes, that when they look at a timber sale, they can fly these things, figure out how much volume of timber is available. They can also, like our petroleum engineer for gravel pits, he uses them to estimate volumes that the contractor has piled up. He can just fly over within 20 minutes, calculate the volume, and we know whether we're getting cheated or not. I mean, and so the whole what I want to show you, I'm going to start with some old technology here that Jim will be able to relate to, of how we used to do things and now how we do things today. So you can see on this very first slide, there's our big matrice. It's a $20,000 LiDAR capable and high resolution orthophoto camera system. It's a huge thing about the size. I guess it's a little bit bigger, wider wingspan than this podium. But this is primarily what I use when I go out in the field. Going back in time, the one thing that I'm mostly going to focus on tonight are what we call stone features. So these are different groupings of rocks that the Native Americans would have piled up, made formations out of for different purposes. And How many here are familiar with teepee rings or the concept of teepee rings? So actually, fewer than I expected. So when I say teepee ring, most archaeologists today are going to say stone circle generically, but I'm old school and it was always so much easier when we called everything teepee rings. In fact, it was easier when we called everything arrowheads instead of projectile points, right? But for mapping these things, initially it was difficult. If you wanted to get good detailed plan maps of a circle of stone believed to be where these rocks weighted down the exterior ground contact margins of a hide covered teepee or lodge. They're the most efficient way in the 1980s is what you see on your screen right now. This the guy I used to work for, he designed something that he called photo boom. So if you can see, there's a two-wheeled trailer with a couple sections of irrigation pipe on it. What you would do is dismantle this, set it up. He had a winch with these angles set up. He had a camera, and the camera had a shutter release on that was hooked to an air valve. So you'd be up, and you have to try to get centered over this group of stones, this circle of stones. You want to be at a 90-degree angle. If you're off, if you're oblique, you're not going to get a precise plan map. But the nice part is you excavate these stones if they're sodded in, cover them with flour. Yes, I said flour, just wheat flour, because it really makes them pop, as you'll see. I still use them with use that technique with drones. But with the photo boom, you'd have to pull this thing into place, set it up, and then take your photos and hope that all your calculations were right and that everything was in focus and that you got all of the feature you wanted, because most of the time you couldn't just get the whole feature in one shot. Well, about 4 years after this was designed, this trailer, and bounced over the hard prairie, it fell apart. So the guy that designed this built an improved one with 4 sections of irrigation pipe and a tandem axle trailer that held up fine. But you see how these guys are pulling this into place? It was impossible to do. We had to use the guy who worked for his pickup to try to maneuver this. Now picture that. He's cussing at me. I'm finally cussing at him. You know, you're trying to back it up into the right position every time. It would take 2 to 3 hours to actually photograph one stone circle. 2 to 3 hours. That's just not efficient at all. Other techniques are the old stadia rod and transit system. And I have fond memories of actually mapping teepee rings and trying to map every stone with one of these and realizing that you've got to get at least 4 points on every stone calculated so you can trace that out accurately when you get back to the office. The other thing I have fond memories of is spending 4 or 5 weeks mapping 600 of these features over about 2 miles. So 4 weeks, 600 teepee rings, 2 miles. The other method, if you're in the field, you don't have photo boom or something similar, or a transit stadia rod, just to map individual features, is this teepee quick method. And this works for virtually any kind of concentrated stone arrangement. It doesn't have to be a circle of stone. It can be anything. The idea is it's set up on a compass. So you've got this board that you put basically a compass on, and you plot everything out into northern sectants, northeast sectant, and so forth. And then you have somebody else measuring the distance and angles, and still you're trying to eyeball as best you can the shape of those rocks. So this method's fairly accurate, but it's not precise. It lacks in precision every time, just because there's so much human error involved. And here's just kind of a cost breakdown that I put together for our department, just to show them how beneficial drones are. And I know I haven't showed you anything on drones yet. We'll get to that. But if you just look through the numbers here and what we've got, and once the money's spent, like just for example, when I said it took us 4 weeks to map about 600 of these teepee rings, stone circles over about a 2 square mile area. Today, we could do that within a day, map every one of these, and the precision would be there. And if we wanted to make precise plan maps of any one of these features, that's also possible with flying a drone over and using the right software. So some of the work that I've been involved with, this is an archaeological site just outside of Helena where we live. And I found this. This is one of the first sites that I discovered when I went to work for the state of Montana. There was a gold exploration company that was doing some work in the area. And they were setting up just a simple drill truck, just drilling cores into the ground. And if you can see up at the upper right-hand corner of the screen, there's kind of a pinkish colored circled area. Just to the right of that, this company didn't realize they were on state school trust land and had illegally excavated just kind of a stair step platform into the side of the steep hill to set up a drill truck. So our petroleum engineer asked me if I would go out, just look at the area, see if they've disturbed anything archaeological. And as I was walking out there, I started to pick up on these small clusters of rock. And when I say a small cluster of rock, most people wouldn't recognize it all. As you see, even here, the archaeology is very subtle. You know, we're not dealing with things like pyramids of the sun or gold foil masks. We're dealing with rock, and usually very subtle, sodded in clusters of rock. So you can see all these black dots on this aerial photo. There's 2 lines. They tend to converge at one point. These things are only about 6 to 8 cobbles each, and they're sodded in, and it's rocky everywhere you look. Most people wouldn't see these. They would just walk right over them until somebody points it out to them. What I want you to look at is that this aerial map is just because of the scale of it. I couldn't get the full length of the lower of the alignments in there and all the cairns, but this is about at 1.3 miles in length. And it goes well off the map to the lower left-hand side there. This particular feature is a hunting complex. You may see it in the literature referred to as hunting architecture. And this isn't for bison. Now, this alignment of cairns that you see is common in bison kill sites in the northern plains. And it's where you get these alignments of rock, usually small piles of stone, spaced anywhere from just a few meters to, up to 10, 15 meters in some instances apart, but usually they're closer. And they tend to converge just before you get to a jump, like the cliff edge, if there was a big group of bison being pushed over or herded over, into a snowbank trap, depending on the time of year, or into a wooden corral of some sort, which is probably one of the most common techniques that we see. At any rate, this isn't for bison. This is something else. If you look at the right-hand side, there are 3 dots, right where the 2 alignments converge. There's 3 dots, and these are hunting blinds. They're subtle rock outlined circles of stone. They're not teepee rings. They're small. They're maybe 6 feet, for example, in diameter. But they're interestingly, they're placed about 30 feet apart, each of them, but they're on the side of a hill that's about an angle like this. So these 3 pits go up like this. The big long alignment goes across a fairly flat ridge top. The short alignment runs up at an angle up a side of a hill, again, that's about this steep. So it angles up across. And I don't know if you've ever watched deer, elk, something like that, when they're moving and they're not disturbed, when you're not pushing them hard, when they're just moving on their own, or they realize that there's something close enough to them they don't like, so they're just going to move out of the area a little bit but not run, they never go straight up. They always angle. And what I think so neat about this is clearly the people or person who constructed this had a tremendous amount of knowledge of animal behavior. This wouldn't be the type of kill where you're stampeding animals through. This is the kind of feature where I'd refer to as passive hunting, where you're just getting animals just to move on their own accord. And somehow these piles of rock, and we think they may have held small, possibly sticks or maybe even brush piles in certain places, just to keep the animals moving away from them and ultimately to their fate where these hunting blinds are at. Oop. So using our drone, I don't know if you can see here. Oop. I may have to actually pull my glasses out. So over to the right-hand side, you can see where I've flowered those hunting blinds. See them? And then here are the cairns that are also flowered. This is high resolution. This is a drone shot from our high resolution camera. And you can see the difference between it at 300 feet and standard resolution, which is this area that's all pixelated. So that's standard resolution versus high resolution. The nice part about the high resolution is that same height. I can zoom in just like that and continue to zoom in on those rocks, those individual piles of rock that you see there that are covered with flour. And it takes more time to actually flower these features, put flour on them, than it does to fly this. And because of the software that we're using called Pix 4D, it flies in a grid pattern and it holds up as long as the battery does for these drones, flies a grid pattern, and you can come back and you don't have to worry about putting a scale down. You don't have to worry about orienting any of this footage or this data to true north. It does it for you. I can go in right now, pull this up in this software called Pix 4D, and I can get an absolutely or nearly precise, within centimeters of precision, of the dimensions of any one of these flowered stone features that you see right there. This is what a typical cairn would look like out on the prairie. This is much of what the cairns in the previous photo that were flowered. This is what you're looking at. And again, if just picture if there was a bunch of other rock around, how hard it would be. There's so much background noise. Sometimes it's really hard to see these things. Whoop, I think I went the wrong way, didn't I? I'm about to panic here. What am I doing wrong? Okay, so I talked about the hunting blinds in this site, flowering the rocks, and this is 3 examples of what we can do with the drone. On the left, I think this is like 200 feet elevation, a flyover shot of the 3 rock outlined hunting blinds on the side of this hill. The one in the middle is what you see in the next frame, the center frame. That's zoomed in. And then if I want to make a detailed plan map of this, make sure that drone is right over the center point, not at an oblique angle, but directly above it at a 90-degree angle, which I've done here. And you can see the plan sketch also that can be created from that. And again, this just simply what you're looking at right here on this picture, this would not take over 20 minutes to do. Now compare that to the old ways, trying to move 4 sections of irrigation pipe into place, and then come back and process the photos, print those out at a large enough scale that you can set down a Mylar sheet and trace over each of the rocks. You can see how inefficient the old way was compared to drone technology and what we're doing now. So hopefully for the Oregon Archaeological Society, this will give you some ideas on what you can do out there quite quickly, quite efficiently. I don't know why I'm struggling with this. So one of the stone features that's out there on the landscape, Jim mentioned, is called a medicine wheel. How many here are familiar with that term? So these things, there's 9 different subgroups currently defined for what a medicine wheel is. And there may be more. It's just that currently everyone we have falls within one of 9 different styles. They don't have to have spokes like the bighorn medicine wheel. And what you'll see here is what we call a subgroup 1 type, which is a large diameter stone circle. So let me go back just a second. When I said teepee rings or stone circles, teepee rings, the accepted inside diameter for a teepee ring ranges from between about 2.5 meters out to 10 meters. So a little over 30 feet, still acceptable size for a teepee ring. Most of them that I've seen will fall between 3.5 meters and 5.5 meters. And then there are a few that are a little larger, 7, 8 meters in diameter. But for the most part, everyone you see is going to be in that 3.5 to 5 meter range out there. This next feature I want to show you. So you can see where the rocks have been floured already. In this instance, I didn't take a before picture. We were running out of daylight. I was out with our petroleum engineer, had about, I don't know, 30 minutes of daylight left. You can see the shadows are getting long, and we were hustling. We had to hustle and go across country, maybe half a mile to get to this. Floured these rocks. He sends the drone up, and what you'll see again was all done in less than 20 minutes. And this is another site. I guess what one thing I wanted to point out was that first site I showed you, the hunting architecture. When I found that, I was always so bothered because I could not figure out a way to map that to a meaningful scale or in a meaningful way. So it took me this long, nearly 30 years, well, 25 years anyway, before I was able to map that thing and write up a site form that I found to be acceptable, a level of documentation that I found to be acceptable. And it's only because of drones. Medicine wheels are another example. I can't, top of my head now, remember how many have been recorded in Montana, but on school trust lands alone, we've recorded 6 now. And it's, I believe that's more than on federal land and private land. Or that's more than on federal land, and that's more than on private land. There's a few less on each of those, but doesn't mean that there aren't more out there. If you heard what Jim said for how much land that we've actually looked at out of 5.2 million acres, it's only about 5% that I've actually looked at. And it's not because I'm lazy. Although I got to admit, walking 9 miles a day anymore sucks. But it's who knows what's out there. You can just see there's 95% of our land holdings have not been inventoried. So who knows what's out there? It's, you know, it's a treasure trove for people who are interested, and hopefully my replacement someday will be just as interested in doing all this. Everyone still hear me? Okay. So this is one example of a medicine wheel without spokes. A subgroup 1 type, if anyone's interested, a guy named John Brumley, same guy that came up with the 4 sections of irrigation pipe and incredibly inefficient way to try to map things. But he wrote this. It's a great work on medicine wheels, and following his criteria, this is a subgroup 1 type. You can see I went out, I floured these, but you really can't see this at any distance except for that central pile of rock, that central cairn that stands out. If it wasn't for the flour on these rocks, you guys would not be able to see anything either. So this was also one of my frustrations. Oh, I don't know what it was, 20 some years ago, when one of our range guys found this feature and he knew it was something, but he just couldn't figure out what it was. And I could see what it was, but I didn't have any way to map this. So it just sat idle until we got drones. So I told you it took about 20 minutes to map this. And this is the result, different angles. It's oriented, the photos are set up to north, true north. And I think one's like 200 feet off the ground, one's 700 feet. And there's just no way to see this. This is about 60 feet in diameter, this stone circle for scale. You see there's a big pile of rock in the center. Sometimes these piles of rock, very rarely, but sometimes do overlie human remains. But most, where there have been some excavation done, they don't. These central piles of rocks are probably the same as what we see today at places like we visited the rock art site down on the Columbia today with Jim, and occasionally you'll see offerings, and these are probably formed through accretion, and throw down a rock as an offering to some benevolent spirit, and everyone else follows suit, and just through time and accretion, these central cairns build up. This is the purpose of these. So there's a lot of ethnographic interviews that were conducted 1920s, 1930s, and the elders that were interviewed, one or two actually contended that he had actually participated in the building of one of these in northern Montana, and the to almost 100% of the time in that night in 100 years ago, 100% of the time, the interpretation is that these are monuments, either to someone who was important or something that happened that needed to be memorialized or made a monument to, or even an animal. But one way or another, they're monuments, they're memorials. That's changed over the years. And so today, contemporary interpretations no longer seem to recognize the monument or memorial aspect of these. There's a lot of contentions that they're cosmologically related, and they may be. I'm not saying they're not. I don't know. I'm just saying you can see how interpretations change over time. I'm still kind of sticking with these were monuments to someone or something that was worth remembering at the time. Here's another example of a medicine wheel, and I know this doesn't show up real well. This is in northern Montana. This is a different subgroup of medicine wheel. And I'll show you in a little bit what we're also doing, just with survey and GIS, and how it ties into this ceremonial landscape that is centered on this medicine wheel. So let me just step out here in front of everybody for a second, but can you see the flowered rocks here? There's a central thick-walled circle, spoke going that way, spoke this way, spoke that way. And that's what you see right here. There's so much natural rock on this eroded landscape that it's kind of hard to see that feature. But this is an oblique view of this medicine wheel. It's a different kind of medicine wheel, but again, it's the kind that the Blackfoot informants referred to as a memorial to someone. Now, the spokes had different meanings to the different informants as to what they meant. In some cases, it was the direction that people came to visit this person who may have died or was just being remembered for some reason. Sometimes it was the directions he went when he went to battle. So Again, different interpretations, but again, 100 years ago, these were typically viewed as memorial structures. The interesting thing about these medicine wheels is a researcher who's now deceased in Canada, and one of his colleagues uh, spent a lot of time inventorying big blocks of land around these medicine wheels. Typically, what we've always done is just find the medicine wheel, record it, not look at much more beyond that. But he had the opportunity to look, he and his colleague had an opportunity to look at an area much larger than just the medicine wheel. And they started picking up other kinds of stone features, not just teepee rings, but other kinds of not, and I wouldn't say unique, but the kinds of stone features, and I'll show you some in a minute, that aren't real common outside of these ceremonial landscapes. And the thinking is all these features, these more unusual or uncommon kinds of stone features seem to have a higher concentration, or you seem to be more likely to locate them when you're near a medicine wheel. And we've got 2 medicine wheels on state land that have big blocks. They're contained within big blocks, 2,600 acre blocks of state land that haven't been disturbed. And I've had the opportunity, when I can fit it in, to go out and inventory these. So I've been inventorying these 2,600 acre blocks of land, sometimes with help, sometimes by myself, for the past 6 or 7 years. And when I'm talking about some of these more unusual features, in the upper left-hand corner is what these researchers in Canada, and I'm going to use their nomenclature, especially when I put this report together, just for comparative purposes. So I'm not coming up with something that's completely different. I want to see how my work fits with theirs. And at the top, you can see it looks like a boulder. So this boulder, for example, is every bit as big as this podium that you see at the top, in the top left photo. And around it is it's not really a complete circle, but it's more like an apron of rock. And then extending off it, if you come down to the southwest end of it, is another stone circle conjoined to it. Over to the right, upper right-hand side, you'll see another similar size. Again, these are glacial erratic boulders. We believe glaciers dumped these things off as they melted away, left them behind on the prairie. And this boulder that you can see in the upper right is now encircled by a teepee ring sized circle of stone. And right next to it is another stone circle conjoined to it. Now down in the bottom center is what the researchers in Canada are calling erratic cairn. And this is just a big cluster of rock shoved up against one side of one of these big boulders. And most of the time they're at least as big as this podium, these boulders. Sometimes a little smaller, but just picture a boulder about this size just laying out there on the prairie. And somehow, I think they're right. The more I see and the more I read, I think these probably are all connected to the medicine wheel that's on these. Now, these ceremonial landscapes, as I'll show you, I'm going to have to define it at the boundary of the state land block. Is that realistic? Probably not. I mean, they could have been much bigger, much more extensive. We simply don't know. One of the problems I've got is I don't have access to the private land. And even if I did, it's now cultivated and totally tore up. So who knows how extensive all these stone features were originally. Another outside of medicine wheels, there's a couple other types of circular stone structures in the prairies, in northern Montana especially. And these are dance circles. And just again, based on ethnographic evidence, they're probably related to something similar to or equal to a sun dance ceremony. This particular one I'm showing you here, I've floured the rocks so they stand out. One thing that seems to be common in these is a prominent cairn in part of the wall. This one, you can see it in the lower left corner, a big cluster pile of rock. And this particular feature is about 40 feet in diameter, and it's on a ridge. It's on a real narrow ridge. It's just wide enough to walk down, and it kind of overlaps this ridge. So it's odd that you would have a dance circle in a setting like that. But again, just think of the difficulties of trying to map something like this if it wasn't for drones. Here's 100-foot, well, this one, let me say, this one's about 80 feet in diameter. And you can see the pickups for scale in the lower right photo. This is another example of a dance circle. And you can see in the lower right corner is an enormous pile of individual cobbles or stones. So these things are very rare. There's only, right now, there's only about 4 or 5 that have even been documented. And I think I've documented 4 of them at this point. Doesn't mean that that's all that's out there. We just need to do more work to figure out what's out there. But this is part of the problem is the longer these sit, eventually they're going to be destroyed through some kind of development. So right now that's my goal, is to try to document as many of these things as I possibly can, just for posterity, if nothing else. Now here's a great example of you're walking across the prairie and the photo on the left side, and can your eyes pick out anything out of the ordinary? Then look over at the right after I after I've floured the rocks in this stone circle. And now pull out the drone. Whoop. And there you go. This is a 100-foot diameter stone circle, a dance circle. And the previous one that I showed you a picture of, these are about 4 miles apart on opposite sides of the Milk River drainage. It's a small river, nothing like the Columbia, in northern Montana. But they're almost in a line from one another, and they're about 4 miles apart. However, without drones, as you can see, I mean, all this work I'm showing you, I know I keep falling back on 20 minutes, but it almost takes more time to flower these things and just pull the drone out of the case and fly it than it does to process any of this data and put together what I need for illustrative material. And this is the plan map of that 100-foot diameter stone circle. I talked about teepee rings earlier. I just wanted to throw in one quick example just so you can see what a standard teepee ring is going to look like. Back to that ceremonial landscape I was talking about. The blue lines, if you kind of go around the outside, this is all school trust land, everything that's bounded by blue. And as you can see now, we've fully inventoried everything. I had to crop off the piece that runs another half mile to the north just because it wouldn't all fit in there. The one thing I want you to kind of look at is just the density of these features. The blue triangles are teepee ring sized stone circles. And then the red small circles are just these little cairns of 6 to 8 stones typically. The medicine wheel itself is right over in here. It's right there. So you can see how everything's kind of oriented or focused around there. Right now, I think the actual total count on just teepee rings alone is about 820. So it takes a lot of time just to walk this stuff, and then we go back with the drone and we'll do a high resolution grid fly over it, and just to quality check the work that I've done on the ground and make sure that I've got everything. And sometimes the drone actually picks up something that I miss. I mean, when we walk these acreages, trying our best to walk linear transects about 20, 25 meters apart, but sometimes you still miss things. And that's the beauty of having this high resolution camera on this drone, is every now and then it'll pick up something that that I didn't see on the ground. One thing that I'm really big into is experimenting. Whenever somebody has an idea in archaeology, I always try to experiment if I can and see, well, does that make sense? Does that really work? And we had an opportunity just to mess around one day, some folks at the agency I work at, and we put up a teepee and put rocks around it. You can see the one question we had is, on a canvas teepee, you have to pull the skirt down lower because today they're staked. They're not weighted down with rocks. So we have to lower that skirt enough to actually set rocks around it. And then when you pull it out, a lot of people said, well, these circles would never retain their shape. If you pull a hide out from under them, the rocks are just going to roll and get scattered everywhere. So there's always been some, or not always, but in the past, there was some debate over, were these really teepee rings for that reason? They should be more scattered. If you're pulling a hide out from under these rocks, they should scatter. And it makes sense, right? So, hey, let's try it here. So as you can see, the circle of rock we made and the orange pieces or markers I wanted to put down just to see how much the rocks moved. And as you can see, they barely moved any when we jerked the canvas out from underneath the rock. Now, would that change with bigger rocks, or even if you're using hide? Maybe. But I think we've got some good evidence here that what we're looking at, what we're calling teepee rings, very likely are probably teepee rings most of the time. One other use for our drones is a LiDAR lens. And is everyone somewhat familiar with LiDAR? Students, what is it? What's LiDAR? Come on. What is it? Tell us. Very good. I had to ask him because I didn't know. I don't really understand it, but he's absolutely right. It's light imaging and detecting, and the idea is it's throwing these lasers down, and based on the density of the vegetation, or whatever else medium is out there that you're looking at, it's sending that signal back. And that's how, I'm sure you've heard of these guys finding these cities, these lost cities in the jungles of Central America, these Mayan cities under that dense jungle canopy. This is kind of a neat, it doesn't always work. And part of the problem is you have to set your calculations up for, are you going over rocky prairie? Are you going over jungle canopy? Are you going over conifer forest? Because if you don't do that right, you may not get any results at all. But this is I think this is a pretty interesting example. The Indians would find this flinty, cherty material. I just generically call it chert, to make certain kinds of stone tools out of, just because for knapping purposes, the flaking is controlled easily, and you can shape these pieces with much more ease than you could something that's much more grainy, right? Does everyone understand what I say when I'm talking about chert? Good. So one of the ways that we identify these sources when we're out there, obviously, is typically there's a pit. If they're digging in the ground, there's some kind of shallow pit, and usually several pits. And a couple instances in Montana, there's one quarry I know just outside of Helena that's over 40 acres of disturbance. Now think about this. These people didn't have metal. They're using antler tines and bones to dig in the ground. And the amount of dirt that was moved over the generations is just astounding to me. But today, over time, these things through slope wash or natural processes tend to silt in. Sometimes you can see the pit. I think on the left-hand side, the photo on the left side, everyone should be able to see a depression there by that tree, right? And then you can see the chert material that's just discarded. This is all just waste pieces. And I've made an effort whenever I come across these to take time to try to find every kind of color and texture that source offers, because there's still a lot of confusion among archaeologists that they can pick up an artifact and say, hey, this came from this church source. And I think I've got enough evidence now to say there's so much color and texture overlap. There's no way you can just look at an artifact and say, for the most part, and say it came out of this source or this source. And this is exactly the same. You can see everything from white, dark gray, brown, red, yellow, grays, and you'll see that in almost every church source in Montana. But after I found this, I GPSed in the points for every pit that I could see on the ground. And I spent a lot of time on this hillside, and it's not very big, but I spent a lot of time there. Wanted to get everything mapped as best I could, but all I really was doing was just shooting in individual waypoints. Hey, there's a pit here. I wasn't getting the actual dimensions at this time, just a point. We went back with the LiDAR lens, flew the big Matrice drone over the area. And remember, you can see in this picture, there's standing trees, there's mature trees all over this. And so from the air, the canopy's dense as far as conifer trees go. It's pretty dense stuff. Whoop. So the green, you can see the density of the canopy from the trees flying overhead. I've plotted the points where I could see a pit or a depression on the ground with the black dots. How accurate do you think I am when we flew the drone over with the LiDAR camera to show me any other disturbance? Any guesses? Throw out a number. Come on. You in the back. Participate here. Nice. Try 50. So right here, the white dots again are my waypoints for every pit that I could see. Look to where the arrows are. All the ground disturbance that I could not see and to this day cannot see. That's under the shrubbery and under the canopy. And this is all old disturbance. It's all old ground disturbance. So you can see how beneficial this drone technology can be in different circumstances. How am I doing for time? When did I start, Julia? Well, does anybody care how late we're here? All right, we're going. So out in the open, a typical chert quarry will look like this. You guys, you probably see nothing but rangeland, right? But can you see that subtle hummocky appearance to the ground surface out there? Just little hummocks. That's all previous disturbance. It's all from previous digging for chert under the ground, extracting it from the shallow bedrock. And this is about 20 acres of Native American surface mining. And it's not, there isn't one or two sources, there's hundreds out there. Now, not all of them require digging and excavation, but there's so much throughout the south half and west central Montana. We only know a fraction of what's out there. But again, one of the nice tools we've got now for mapping, as you can see, is this LiDAR technology. And it can help us be much more precise on what we're collecting for data. And quite frankly, just show how limited we are with just our eyes. This is something that I think Jim would probably recognize. I don't know. So I told you Jim and his crew have been great about coming all the way out to Montana just to volunteer their time to help out. This is a rock art site I hope Jim can publish on for years to come. It's really spectacular, and it's am I out of line, Jim, to say it's the most important rock art site in Northwest Montana? Yeah. And this is on instead of a vertical face, these images are all pecked into a horizontal bedrock outcrop. So it's basically like walking right across this platform right here with images pecked in. And I believe they span, from what we can tell right now, about 160 meters in length, 170 meters maybe in length, continuous across this bedrock shelf. And this is in part flying a drone over, but all these images is what Jim and his crew, and they were gracious enough to let me actually help them. I don't know if I was helped, but I participated and learned a tremendous amount about mapping these petroglyphs. Uh, these are laid in place precisely over the pecked images. Now, at this particular site, these images are so subtle, most people don't even know they're there. They're weathered, they're old, they're very subtle, they're hard to see. We flew a high resolution drone camera over the imagery. And I can't remember his name, Jim. Who was it came from all the way up from Las Cruces to Mark Willis? Incredible guy, but I think this just smacks to how important this site is to people. Jim gets this guy's been working in Central America, South America. He's running these drones, LiDAR, and all this high resolution photogrammetry work. This guy drives, like I won't say in a day, but he drove straight from Las Cruces up to Northwest Montana just to participate it in spend a day just participating with us in this. And then Jim's good friend from Italy, the rock art expert there, Angelo Facchetti, he comes out too. I mean, this was really a big deal. And part of what is going to add to all this is the drone technology and the drone work and the drone imagery. And you can see how these things stand out so much better than they would if you're just looking at them on the ground. You probably wouldn't be able to see most of the images as clearly, at least, and maybe not, and maybe even not most of these images in the left side photo, if it wasn't for this LiDAR. I think this was one of his LiDAR. No, it wasn't. It was just high resolution photogrammetry. The other uh, is probably the most visible of the petroglyphs out there, or at least one of the most visible, um, to the right. And I wanted to show you just one other thing. We're just playing around one day, and this was before Jim came out to do his work. The Department of Transportation had just got some new total station LiDAR equipment, and somehow I can't remember who I was talking to there, but they were going to be in the area. They were looking for something to do, so they came out and they made a topographic map. They just set up this total station. Different. It wasn't drones. This was all total station on a tripod, and collected all this data. But all those green lines are like in 1 foot intervals, which is almost ridiculous. I don't really think this helps much, but it should give all you guys some ideas on other uses for LiDAR technology other than just looking through the canopy cover that's out there. In this case, it's fairly open and it's all cliff, and if it's probably more easy to actually visualize what this setting's like without this map interfering with everything, but it's pretty much just a cliff below the yellow dots, vertical cliff, and then it gets real steep to the right hand side of those dots as well. And again, just quickly trying to get a nice general setting image. And this is just a standard drone shot. There's nothing special about this at all. But again, it really helps out with trying to illustrate the site settings, where these sites are at, anything on landscape that you want to show in addition. this is just any cheap drone you can send up and take a picture like this from. Looking back across this rock art site, that whole flat ledge that you can see across the water, that's the site area. This drone in this case was sent out over, there's a lake right below this rock art site. So access obviously to get this photo would be very difficult, if not impossible. But with the drone, you can overcome some of these limitations by sending it out over the water and taking photos at any angle and any height you want. Okay, so I guess that's all I've got right now for drones and for the work I've been doing. Hopefully this will give you guys some ideas on who to talk to or how to use this technology, and again, how efficient it is. As long as you've got battery life, you can fly and collect as much data as you would like.
Thank you very much. And now, if anybody has any questions, I got one up here.
Can you adjust the frequency on the LiDAR to get help on a resolution, say in heavy forest cover or brush cover, or can you adjust the frequency to improve your resolution?
Yes,
And you can't?
you can, but you really need the folks who are experts in using the software to set that up for you ahead of time. And that's why I said we have an entire bureau now dedicated to just GIS technology. So they set that up ahead of time before we take the drones out.
Okay, have you used infrared to look over a site?
No.
To see buried sites? You haven't used that? Okay.
No, I've never used infrared.
Okay.
Any other questions? Got one here.
Have you used any other types of mapping technology to map these sites?
What I use is exclusively just GPS technology, and then our GIS technology involving the drones and the Pix 4D flight software, and then the LiDAR. So that's all I've used as far as modern digital imagery goes. But if you guys have ideas, hey, love to hear it.
Question here.
How much flour do you use when you flour the TP rings?
It's a great question, and actually I was burning through a lot, and so if you're interested in this, the one thing I'd recommend is you contact your state grain lab. I'm sure, seriously, because they're always processing samples, and they get literally tons of grain samples that they turn to flour, and then they just throw it out. So I can get it for free. Now the problem is it's not bleached, so I would recommend mixing about 20% bleached flour that you're going to have to buy with the other just ground up wheat flour. How much do I use at a time? So just a measuring cup, a 2-cup measuring cup. I go through about 6 of those on average per stone circle. Those 6 times 12 cups of flour per stone circle.
How much bread is that? All right.
You had talked about how you need the photos or the drone immediately above it to take a proper image. Is that done using the transects? Like, are you able to get it to line up, or do you have to go back over those sites?
So I'll set something down in the center of the site, and I just take a tape measure out there, 2 tape measures, run them, try in on the interior, the longest lengths on the interior, try to find that point. Then I'll set something down there, even if it's just a stone that doesn't look out of place, and make a note of that. And then we have that drone centered directly above that on every feature. Whatever that point is, I try to find the central point first. So that's a great question. And that's how I try to make sure everything's a vertical imagery so that it's all precise when I make a plan map of it. No, yes, just visual. I'm right out there in the field, and whoever's operating the drone, he's right beside me. And so I can look, in real time at where that's positioned on our iPad and line everything up like I like it. And once I'm satisfied with the photos, then we move on to another one.
Hey, so I'm really interested in the way that you use the drones in your department, and when you're mapping an archaeological site, are you also collecting data that's used by the the geological prospectors, the forestry people, or are you running surveys of these sites separately from them? And then I guess a follow-up to that would be, how does that interact with your process of identifying cultural resources on the ground, and then marking them to be showing up on the drone image?
Yeah, great question. So typically, first of all, let me explain why I even have a job at the state. So there's a law called the Montana State Antiquities Act, and it requires all state land managing agencies to consider the effects that a ground disturbing activity that agency will authorize, what the ground disturbing effects will have on a particular cultural resource if it's evaluated, determined to be significant, so forth. Much like the federal law, except there's a couple things cut out of the state level one, and we have more flexibility. So much of the time, like these ceremonial landscapes I'm showing you, there's nothing proposed there. It's just an interest project of mine that I've been working on. Most of the work I do, though, it's because it's a compliance-driven project. So let's say we have a gravel pit proposed or a timber cell proposed. I'll go out and look at that ahead of time, and if I find something, I'll make my recommendations. But the mapping and the documentation of that all goes into a database that I maintain for our department that's accessible to all the other resource managers. So they can look at that as well and talk to me. I mean, nobody's just looking at it saying, no, there's something there, blah, blah. They talk to me. We're all actually, I mean, it's a neat agency in the sense that everyone does seem to talk to each other. So I'm never left out of the loop. I'm not doing something independently of everybody else. And my input always has to come before the projects get authorized. Doesn't mean I have the final say, but it's all taken into account, what I put together. And that data is stored so it's accessible to me or to some other resource manager. And so I guess that's how it's set up for us.
Real quick, I had one right here.
How long does it take to flower a Sundance circle?
So you saw that one medicine, let's just say the medicine wheel, because that's a great example where we were running. And of course, after I run a quarter mile, I'm kind of like this. So breathing hard, try and throw flour out on that 80-foot diameter medicine wheel before the sun went down. That took me about just under 20 minutes, maybe 15 minutes. You can go quickly. I mean, I've got a bucket of a kitty litter bucket, for example, full of flour and a 2-cup measuring cup. And I just walk around quickly and just sprinkle it on the tops of all the rocks. You don't have to coat them precisely, just get enough of them that they're going to stand out. Then when you look at them in that imagery, you can easily circle the exact shape of the rock. One thing I was telling you about before, whether it's the transit stadia rod approach, the TP Quick mapping board approach, you're always to some level getting frustrated and just guessing what that rock looks like. The drone approach, you can see the rock, so you can always trace it. Now, that's going to change if you actually excavate those stones and clean all the dirt off them. Even in teepee rings, in my experience, when you excavate a teepee ring, especially if they're sodded in at all, you can expect anywhere from a 20% increase to about 120% increase in the number of rocks. So, and I've got some, I don't have them here, but ones I've shown what it looked like before I started the excavation, what it looked like after complete excavation. And they look in some cases very dissimilar.
So what I'm hearing is you need a second drone to flour all the rocks ahead of time. Yeah.
That's right.
So I noticed that a lot of the rock formations were placed on like ridges or like high points right at the edge of a cliff.
Right.
Is there like a known reason for that or?
There's not, and some of this may be bias because think about all the ground that's been plowed up. Most of where we find these dance circles, medicine wheels today, that I have found anyway or recorded, they're not in areas that you can plow. And the one medicine wheel, do you remember where it had the spokes coming out? It was really kind of hard to see. That's not in a high point at all. It's actually in an obscured swell in a low point. And oddly enough, there's a small mountain range called the Sweetgrass Hills that are on the Canadian border, partly in Montana, partly in Canada, mostly in Montana, partly in Canada. And the guy I told you about or the folks, I should say, in Canada that I told you about kind of define these ceremonial landscapes. So this Barney Reeves, when I was talking to him about it, he was sure everything would point to these Sweetgrass Hills. All the features, if they had an opening, would point to the Sweetgrass Hills. The medicine wheel you should be able to see the Sweetgrass Hills from it. You can't. And interestingly, most of these features, you can see a different low feature on the horizon to the west, not the Sweetgrass Hills to the northeast. So they're not always on high points. And even if they were historically, it's so hard to tell how much has been destroyed through like cultivation or other kinds of development.
Hi, when you are creating your map graphics, are you creating those in ArcGIS and then making features
Yes.
and ortho-rectifying them? Or are you doing something like Illustrator where they're not necessarily accurate to size?
So it's kind of both. So I start in ArcGIS and then I'm using Corel Draw for some of the imagery. It's just an overlay. So I'm just coming back and just plotting a symbol over a symbol.
Okay. I got 2 questions.
Okay, I was curious, what is your optimum altitude for your, for good resolution, optimum altitude for a drone? And what is your GPS error range, plus or minus centimeters or whatever, how many?
Yeah, I'm
Sure.
not, first the GPS question. So it's meters. I'd say it's plus or minus 5 meters.
Plus or minus.
Yeah. And that's just standard recreational grade equipment. I don't have survey grade GPS equipment available, so I get sub-centimeter actually. The other question on the flight, it depends on what you want to do with it. There isn't really an optimal height. As you saw in some of those pictures, up to 700 feet, I can actually, with that high resolution camera, zoom in well enough to make the same plan map. So it really just depends on what you want to pick up.
So what's the largest ring you found?
The largest dance circle is that 110 foot diameter one that I showed you. Oh, of teepee rings? There's some in the 10-meter range that may or may not be true teepee rings. They may be something else. The largest in general would be 7 to 8 meters. And any guess on out there on the plains when teepee rings seem to be at their biggest in general, not 100%, but just in general? Jim? Jim should know. No, that's 70s thinking. Jim's PhD dissertation was on Basant, a culture called Basant, about 1800 years ago and up until the time of the bow and arrow, about 1500 years ago. And these folks were they kind of, they were the epitome of bison hunters out on the plains, this Basant culture, the last of the atlatl and dart users. And believe it or not, the radiocarbon dates that we have so far, they would say that Basant rings tend to be the largest in diameter at that time period. So that's well before the introduction of the horse. Yeah. See, I can make up things too. And no, no, it's true.
I've seen you conducted experiments on how rocks move
Mhm.
after you like pull out the hut.
Right.
I was wondering if you conducted any experiments on how artifacts in rocks like erode and change with the weather over time, and if so, what type of experiments we as students could conduct to see how artifacts or rocks evolve over time. That would be safe.
Well, I have not conducted an experiment like that. The one thing that comes to mind is you know what an ant farm is, where you look at, well, there you go, get some damp soil and put it in the freezer and just see if over time, whatever you've got layered in the dirt moves up or down. And I think it does. There's certain settings in Montana, especially like the foothills of mountains, just notoriously bad for having nicely stratified sites. And I think a lot of that is to everything from what we call bioturbation, could be everything from small burrowing mammals, rodents, down to earthworms. I've seen studies on how much dirt and artifacts earthworms can move over time. But so it's a problem if we're trying to separate out different occupation events in a site, talk about the age that these places were occupied, you know, over time, it should look like a layer cake. But if it's all jumbled together, you just don't have that kind of confidence in what you're talking about. And that's a problem, especially in a lot of these foothill mountain sites.
All right, and last two questions.
When after you're mapping with the drones and stuff, when you actually go to excavate, how do you utilize land survey? Because that's what I do. So how do you use land survey in the archaeological process?
You have to explain what you mean by land survey to me.
So using like the total stations
Mm.
and mapping, like the grid, and as you're digging it, maybe using scanners and stuff like that.
Right. So the one approach I think you've probably seen, especially if you've ever watched anything on like Egyptology or Egyptian archaeology, you know, it looks like they're trying to shoot everything they find, or Mayan archaeology, for example. These guys are out walking around shooting in every piece in place. My method's a little more crude than that. So let's not talk about stone features. Let's say we're excavating a site. So I'll set up a datum that anyone can come back, find one of my corner pins for an excavation unit. And then I've got a grid, a 1 meter square grid that lays over the top of every 1 meter square excavation unit. And it's broken down into 10 centimeter squares. So I don't piece plot like with a transit rod or a drone flying over to piece plot every artifact. And hopefully this is what you're asking.
Yeah.
So I've got a map on the back of a form. I just stand directly over that square broken down into 10 centimeter squares, and I draw in every piece of cultural material or things I want to keep track of within that 10 centimeter square. And then when I get back to the office, I just edge match everything and put it together that way. Some of this is just a matter of, again, it's not being lazy. It's just a matter of how much time and resources do you have available to collect as much data as you possibly can. And some of the sites, I mean, when I'm talking about site excavation, these are all sites that are in danger in some way. They're either being eroded by a creek, there's, you know, buried cultural material being washed out, or the case of there was 12 teepee rings that had to assemble a crew to fully excavate because it was going to be cultivated, and there was no way to stop it. The governor at the time said it's going to be worth more to the state to actually turn this into a grain field than just to leave it set idle. And so again, if I wanted to do anything, it had to be entirely up to me. So it's easy to find volunteers, as you folks know. I mean, if somebody called you up, and you had time, I'm sure you'd go out and help. But it was great. So I had 2 years to delay everything, and we fully excavated 12 of these teepee rings.
All right, and final question for the night.
Most of these things that you have found were like
You're good.
evidence of like hunting and gathering and like stone features, but how often do you find evidence of like horticulture? Or where would you look, or what would you be looking for if you were looking for evidence of horticulture?
Yeah, most of the land that we have, state lands, wouldn't be on the like the lower part of the Yellowstone in Montana, the northeast or eastern side. There are some actual village sites there that are probably horticultural based in some part, but that's all on private ground. So that would be where I would look. I haven't found any evidence of horticulture anywhere else that I've looked on school trust land in Montana. And most of this is just because of what land we have. I mean, those lands were all filed on before homes or before statehood. And that's when school trust land came in. It was 1889 when Montana became a state. So anything that was already filed on privately wasn't going to go to the state, obviously. So does that make sense? So the better agricultural areas is where I would look for this evidence, but generally that's not in the school trust holdings.
All right. Thank you so much for staying and answering all these questions. and
Thank
giving
you.
us time. It was great. Amazing. And thank you to everybody for showing up here at OMSI and online on Zoom. And we have another meeting next month, the first Tuesday of the month, November 4th. Caitlin McDonough from the University of Oregon giving a talk on points of connection, the Western STEM tradition. So,
Well, does anyone want to hear another presentation? I got plenty on this.
and stick around for an encore presentation.
Okay.
No, manufacturer, just real quick, we gotta go. Manufacturer the drone. That's it.
Matrice,
Matrice?
yes. MATRICE. It's about a $25,000 drone.